Hello everyone and welcome to another research and development video. This time around we've got Mr. Nelson Lakay joining us, Lee Renow and myself, Jason Busby. We're taking a look at what Lee has been working on with the terrain system, but the focus is not so much specifically on the terrain system implementation that Lee has at the moment, which of course is still in just a development state. But it's time for us to start discussing persistence, the ability to keep the manipulation that is applied to our vertices stored somewhere so that when we come back in, those points are exactly where we left them. So as we begin sculpting, smoothing, raising, lowering, etc., that information gets saved. Because Lee, right now, you get in there and you start painting and having a good time, but as soon as you stop, it's all gone, eh?
But not only that, the moment I start walking away from what I'm painting and I go to another part of the map and turn around and walk back, it disappears again.
That's a very good point. Absolutely. Now, Nelson is completely new to what Lee has been doing, and to be honest, I am for the most part, because this is the first time that I've had a look at any of the code that actually contains things such as his thread pool and the ability to sculpt on terrain. But I want to point out that that is completely irrelevant to this discussion, though I think we need to kick things off with at least a look in the terrain patch class and talk about how our terrain is generated. Just a quick overview for Nelson. And then from there, we need to start discussing how can we use RavenDB to hold this information. So, Lee, if you want to start out by just giving Nelson an overview, and myself, since your code's a bit modified here, we're just going to go right into terrain patch and start looking at patches being generated.
All right. Well, the current method of generating a terrain is all based off of a height map. So if I jump over to Photoshop, here is the height map that I'm using currently for generating our terrain. Now, if you look at it, it's, fairly uniform, and it's got some high spots, those being the white spots. It has some dark spots, which are the low spots in the terrain. But the important thing to know is that this is only 248 pixels wide by 248 pixels high. Now, with a world of the size that we have, that's not a one-to-one relationship between our vertices and our height map. Obviously, we couldn't. If that was the case, we'd only be able to build worlds that were 2,048 meters across, which is nowhere near what we've demonstrated in the past. Now, the trick to accomplish this is done by using this map and scaled up to our final scale that we want to mess with. So what I'm doing is I'm sampling this exact same texture over and over and over again, but I'm using different scales and different weights of sampling when I blend it all back together. So in this case, the very first time I sample it, I'm scaling this thing up probably about 300%. Or not so much 300, more like 3,000%. I'm using 0.03, so it gets quite large. And then I do a calculation based on where that vertex is in unity space, and then do some fancy math to interpret where that would be on this position inside of the map. Once I get that position, I then sample again at a different scale, and then I pull that point and I blend it with the first sample I've got, and I do it, I believe, 6 different times. What that gives us is the effect that we have large land masses that have some smaller details on them, and those smaller details have yet smaller details, and smaller all the way through. So if we were to look at it, I could quite easily show just the very first pass, which might help visually represent what's going on. So if I go over here and I take just the last sample, which is height 6. So, and these are the scales that I'm using here. These are the weights that I'm using to calculate. Here's where I actually pull the samples. This is where I do all the blending for everything. But height, this is the final height that comes out, and I modify it a little bit to do an exponential curve for determining scale of mountains, because things close to sea level, I don't want to be so mountainous so they're knocked down in height, while mountains that are thousands of meters high are kept very, very high. And the same inverse with under the water features. But just by commenting this out and using only one sample point, if I go ahead and build this, if I can reach my keyboard, and then jump over into
Did it actually get saved?
Yes.
I just saw the asterisks.
Well, I turned the arrow off, so if you look, no, it didn't. What's going on? All right.
If you built, it would have saved. I don't think you're hitting Control-Shift-B. There you go.
Yeah.
Yeah, I think whatever combination you hit, because I know you're not right in front of your keyboard.
Yeah, probably fat-fingered it. So, all right, so we build it. If I go ahead and run it, now this should demonstrate a very common problem if you scale a height map too much.
Now, very slow movements here, since we're capturing this off your screen 750 miles away.
So if you look, what we end up with is a very stair-step landscape. And this is what happens when you only sample a height map and you just try to scale it up to fill the whole world. There's not enough visual detail in that height map to make the world seem realistic. So what I do is I sample it once, scaled up to full size like this, and this is the result I get. Then I go ahead and I use a smaller scale and sample again, and then blend those two samples together. And then I do it again and again and again. And once you do it many times in a row, you get something that's much more believable. So if I go back and I go ahead and set it back to the way it was, with all 6 samples being brought into the equation. Whoa, keyboard. Gravity does work. So if I build again, hit play, what we end up with is the result of all those different samples being added and blended together. And we get something that looks much more believable. All from the same 2K terrain texture.
Interesting. But would it ever be feasible to use a height map that is large enough to represent every meter with a single pixel?
No. For this world, we did the calculation. I think it turned out to be about 600 gigabytes of data if you wanted to save a height map that was large enough to cover the world that we're representing here with a 2K texture.
But with all that averaging, it's going to be nearly impossible to individually sculpt out any piece of this map.
Not at all. I can come in here, switch into my tool, scale up, and just start painting.
Right, but you're modifying the pixels after they've been, or the train data after it's been generated from the averaging of the height map, right?
Exactly, and that's what you're going to be helping me save is differential information. We're not going to save new height map information. What we're going to do is we're going to save only the vertice height information of patches that have been modified, and we're going to save the displacement from the generated height map information. So where I've added information here, this has a height that's calculated. So here we'd say, well, that's 3 meters higher than it was before. So the map that we'll save will say +3, +2, +1.25. If I decide to go ahead and push down on something, this would say -1. And that way we can still save massive worlds using very little data, and then only the patches that have had an artist's touch with custom painting will we need to save that differential information.
And very
then
much,
we can stream that.
correct me if I'm wrong, but it's very much like real world. You know, we show up and there's already mountains and everything else, and we come in with our bulldozers and clean out areas and make towns and cities. And but you know, the beautiful Rocky Mountains were the way they were for millions of years or however long, and that's what you're looking to achieve here, right? Minimal data storage.
Absolutely. What I want to be able to do is have the ability to pre-generate the world using a preset piece of information, hence that height map, which is this guy. So the nice thing is with this, an artist can come in here and design this map and lay out mountain ranges in a spot, put an ocean over here, put lowlands wherever they want. So you can sculpt the continent the way you want it to, and then we could use either the same thing, the same texture if it was tileable, or come in with a separate texture that was tileable and use that to add all the little noise procedurally that doesn't have to be hand painted, but it will be the same every single time we start the game. Then if an artist goes in and looks at what's generated, goes, that's not quite right, or I need to carve out a passage through the mountains for this road to go, they can go through with the tools, paint that in, and then that gets saved into a database, which then can be either streamed, or we can come up with some sort of format that can be saved out and included with the client. But if we have the mechanism to send back and forth to a server and stream this thing live, we then gain the ability to have multiple artists working on different parts of the terrain at the same time and send those updates back and forth between each other. And the trick is to get that information as small as we possibly can to optimize the storage of and the transmission back and forth.
Right, but like you said, it ultimately has to be some sort of two-dimensional array with stuff in it. But if you make it a two-dimensional array, then it's going to be the 63 gigabytes.
No, it doesn't have to be, because...
All right, now do you want to bring up your blue board and start drawing?
No problem. It won't have to be, because it will take up those points that you were talking about. I'm going to go ahead and shut this down, get a little bit more processing power back. Now, I've got this little guy that some of you have probably recognized from the forums. Now, each one of these intersections is a vertice.
Vertex.
Or, yes, vertex. Each vertex is each one of these dots is a vertex. They make up a whole bunch of vertices. Someday I'll get that right. But you're right. If somebody was to go in here and save a bunch of changes, then we have to keep information for each one of these points. That would be if an artist went through and made modifications to every single patch in the world. Most of the world isn't going to be hand sculpted, hence the procedural part. Gives us a large world that doesn't have to be modified, and then the artist can only have to go in and modify the specific sections that they want. So what you end up with is a subset of all the possible terrain patches that do have changes. Now those changes are, if we encode them correctly, which is one of the things that this discussion is about, is how can we encode that efficiently. We could do it with as little as 2 bytes, and we could save those 2 bytes in an array. It doesn't even have to be a two-dimensional array, because we can very easily mathematically figure out, based on our number of vertices in each row, when we need to wrap that array around. And then once we've done that, we could also use, say, run length encryption on it to make that information even smaller. And then you only need to save that.
Encryption or compression?
Or compression.
Oh, okay.
Yeah, I was thinking...
I was like, I don't know if it's actually going to be smaller, but it'll definitely be more secure.
Yeah, well, we'll do both now. But we could use run length encoding compression to shrink that array down even smaller and use that saved to the database. So when a person moves into a new area, they could go and prefetch all the needed compressed pieces.
Which works, and so I just want to back you with this, which Nelson, let's say that the artists do go in and manipulate just millions of points and we have a massive database full of all of this data, the ability to go in here, sort and send or stream out to the client only what's relevant for the area in which they're in or about to be in means we're dealing with very small sets of data.
Did you say that the entire differential patch is only 2 bytes?
No. That each point, each vertex in a patch can be represented by 2 bytes.
Yeah, that's been like bugging me for the last 10 minutes. But so cool. So that's how big a patch is in your system, at least. How many? What's the size of your patches?
Well, that is going to be subjective depending on what platform we're ending up building for. The system as designed right now can accommodate pretty much anything up to a max of 65,000 vertices, which is about 254 by 254. We don't want to go that large because, one, it takes forever to generate them. Two, it will bog down the system. What we found right now that seems to be a good number is 49 by 49.
But being able to drop the patch size down allows us to cater better towards mobile devices.
Mm-hmm.
Right.
And which was something that I was playing with as well. And we can adjust the numbers the way we want, and we still get fairly decent results. If I go ahead and drop this down to, say, 17, which is 1/3 of what I had before, multiply this up by 9. So I'm dropping the number of vertices, but I'm maintaining the space relationship between the two of them. So the size of the world will be consistent, but just a much smaller.
Hold on. 16 is not a power of 2, is it?
No, it doesn't. That was something else that I need to bring up. One, I was using LOD. This had to be a power of 2.
Okay.
This only needs to be an odd number now. So an even number plus 1. So this could just be, remember to use.
That's interesting, though. While he's changing that, that's an example of technical debt incurred by using comments in code. But anyway.
That's pretty much why I hate using comments.
If you use comments, you must maintain your comments.
Yeah. All right, so we can resize this, maintain our space relationship. If we go back over here and hit play again, we end up with, I'll move slow.
But yeah, we're still coming in on the side of a hill.
It's the same world, and directly in front of us is still this littler hill with this hill further off in the distance. And if I scroll back over to the mountains and run up this hill, we still have the same mountain range back there. It has less detail, but it's still there, and we're using a fraction of the amount of information that we were using before. We're now only using 17. A grid of 17 by 17.
Pull up your stats dialog. How many draw calls do you have at the moment?
It's going to be the same.
Oh yeah, of course.
Because I'm still using the same number of patches.
Yeah, absolutely. Yep.
But I mean, for a lot of MMOs out there, this is about the quality of the train you'll get.
Mm-hmm.
And you can literally drop this number down quite a ways and still get fairly believable results. I've gone all the way down to...
What about leaving your detail up and having less patches drawn?
That will kill your draw calls, or it will drop your draw calls. But your view distance has to be brought in because now you can't see as far.
But again, on a mobile device where you've only got like 3.5 inches or so.
Right. Then we'll get into the problem of how many vertices and how many calculations a mobile device can truly handle.
But you are indeed dealing with a fewer number of vertices just by the simple fact that you have less mesh geometry or data that you're dealing with.
Correct, but whether or not the device is even capable of doing a grid of 49 by 49 is what my concern would be. That might just be beyond its capability to do fast enough. But without building out to a mobile device to test it, I won't know for certain until we do that.
Yeah.
So, though a concern that
just doing 9 patches is cut the draw calls in half, a little bit more than
Actually
half.
down to about an acceptable for an iPhone.
Mm-hmm.
without any objects on the train.
Mm-hmm.
But the thing though that if are you wanting to store patch in because I'm assuming each patch has an X and a Y position.
Yes.
So you can uniquely identify each patch.
Yes, each one has an offset as well as a position. All I need to keep track of is the offset, because by knowing the patch size and its density, I can recalculate its position. So I just need to save its offset, which is an integer. So it needs 2 integers, one for X and one for Z.
And the offset is the amount of patches it is away from the center.
Yes, both positive or negative.
In that case, wouldn't we be coding ourselves into a corner if we persisted the concept of a patch, if you were wanting to have different patch levels on both the PC and a mobile device? Is it possible to persist the data ignorant of patches and have that calculated based off of what was asked for? Because if you're talking about having the patch size be different between devices, then you should really make the data store agnostic.
Well, that's why we're talking to you to figure it out. Now, there's another problem with building terrains to multiple platforms, changing the size, because as you saw, we incur some smoothing. So the same information isn't going to be 100% consistent. So where you've got a hill of X height in the PC resolution, once you drop down to, say, an iPhone resolution, that hill may actually be 4 or 5 meters lower, which means anything built on top of it would be floating in the air. That's something else that we have to.
That's why I'm interested in. Now you're saying that was if you actually took the density of your mesh down, right?
Yes. Once you start changing the density and the spacing of the mesh,
exactly,
the sampling gets shifted, so the
right,
heights
and
are going to be different.
And that concerns me, especially with the server verifying a client's location.
Right.
Yeah, that concerns me actually quite a bit. But let's just put that off to the side. I'd almost be more interested in locking in a specific density and then being able to control how many patches are being drawn out and pulling in our fog and clipping distance, etc. As again, that comes down to if the mobile device can handle the density that we're dealing with.
Well, that's if you're planning on using the mobile device to show a real representation of the real world, which was something that we hadn't really thought about doing. It was supposed to be more of a visual tool type thing and not them really playing as a real client.
Oh, okay, I see what you're saying. Yeah, and with that being the case, absolutely. Though, as long as we can, I still love entertaining the idea of being able to run around on the iPhone or the iPad in the world. But yeah, you're absolutely right.
See, I was thinking more it would be like a virtual, almost holographic projection you're running around in it. So
I see.
Just ideas, I don't know.
Yeah. But anyways, okay, so back to what you and Nelson were talking about.
Right. But where he was talking about is would we want to be able to use the same painting information across multiple patches? The cool thing with sampling the patches and going down lower, as long as everything's painted on the PC client at the higher resolution, though that information can still be sampled and interpolated and applied to the smaller patch. I can use the same information. I don't have to have 2 different sets of offsets. Okay. Which is the same thing that is happening with this height map information. If I get my mouse back and jump back, and we look at the height map, I'm sampling, and at every point I sample, there's not necessarily a pixel at every point. These pixels are going to be at regular intervals, 0, 1, 2, 3, 4. A point that I might be sampling might be at 2.5, and there's no pixel at 2.5. So what the system does is goes, oh, I'm trying to sample at 2.5. It goes, no, there's no point there. Okay, we'll take the pixel that is at 2 and take the pixel at 3. And then, okay, how far between am I? Oh, I'm halfway between. Okay, average those out. If I was at 2.75, it'd go, okay, well, take those two and give me the point or the interpolation at 75% towards the third point. And it just calculates all that out, plus runs through all the different samples, does the same thing with each one, and blends that all out, gives you one final number that it spits back out to the grid creator, or the create grid method, and it uses that to assign the height to one of these points, one of these vertexes.
Okay.
And then, yeah, what you said, one of these vertices. So then what would happen is after we've got this height back from those calculations, it would then go, oh yeah, I've got information that, a custom offset layer. And then it takes the sample point at that position and adds or subtracts it to that. And I would also, try to save other things inside of that as well.
How does that work if you're running at a lower resolution and you don't have a point right there?
Then I do the same thing I do with the height map. I don't have points at every one.
Right.
If, let's say this was a lower resolution, and I've got, let's say, a point here and a point, I'm sampling a point here and a point there, I would take the next nearest points, interpolate between them, and make up a point in between the two.
Okay.
So that's where it would come in. It's basically best guess. And then from there, I also smooth it and try to make it look all nice and pretty. And at some point, I have to go through and recalculate all the normals at the seams, because those aren't calculated correctly, and you can see those on the train. But that'll come later.
Yeah, I saw that. All right, let's do this. We're at just over 27 minutes now. Let's go ahead and bring this video to a close, and we'll pick the discussion up in the next video. Thanks a lot.